Welcome to Practical AI. If you work in artificial intelligence, aspire to, or are curious how AI-related tech is changing the world, this is the show for you. Thank you to our partners at Fly.io, the home of changelog.com. Fly transforms containers into micro VMs that run on their hardware in 30 plus regions on 6 continents, so you can launch your app near your users. Learn more at Fly.io.
Welcome to another episode of Practical AI. This is Daniel Whitenack. I am the founder and CEO at Prediction Guard, and I'm really excited to talk to another founder today in the AI space. Today we have with us Shahul from Ragas. He's one of the co-founders. Welcome, Shahul. How are you doing?
Hey, I'm doing good. Hi, Daniel. Hey, folks, for hearing me.
Yeah. Well, thanks for joining at a late hour in India. Appreciate that. But would love to hear a little bit, maybe for those that aren't familiar with what you're doing, maybe share a little bit about what that is, and also maybe how you came upon the types of problems that you're solving with your current work.
Sure. That's a very good place to start. So about Ragas, Ragas is an open source library for evaluating LLM applications. And what we are trying to do with Ragas as an open source library is to provide the developers or AI engineers who are building LLM applications the tools and the workflows that are necessary to automate or partially automate the process of evaluation through using different techniques, different methods and techniques that we bring out through Ragas. And how we came up to the idea of Ragas is basically me and my co-founder, Jitin. We have been working in ML for the past 6-7 years. And when LLMs came out, we were already working with large language models. Jitin mostly worked on the inference and infrastructure point of it. And myself, I was working as an applied researcher. So we were, practically, we loved it. We were practically, doing a lot of experiments with it. We were part of different open source initiatives, building LLMs and also using LLMs to build different frameworks at that point. Even LangChain and Lambda Index was coming out as one of the earlier frameworks at that point. This is around early 2023. And we were also working with different applications and stuff. And RAG was one of the most popular applications that went into production very easily with LLMs. And this is one of the first things that LLMs actually opened up as a possibility for enterprises to build something on top of them, which can save a lot of time and money for them. So we were also building RAGs, and we after a couple of experiments with some clients, we found out that okay, we are able to build these LLM applications, this RAG application using any LLM. It has different moving components, and going forward, there will be a lot more moving components to any LLM applications. Like it will be something like a compound system where there are, as you can see now, it's like not only RAG. Now it's like tool use cases. There are different emerging to that constitute a compound system kind of stuff. And we thought, okay, why don't we build some evaluation metrics, few evaluation metrics that can be used to understand the quality of any RAG application that any engineer is building. And we ourselves found out that going through these answers or going through these intermediate results manually is not a scalable approach. I could rephrase it to say that it's a very boring thing to do and nobody is very keen to do it. This is something everybody will push into someone else's responsibility, but it is something very important too. So we thought of identifying methods or coming up with solutions that could help developers do the evaluation, but also save them a lot of time while doing it. So it should not be something like, it is basically an evaluation of LLM application, regardless of RAG or any agentic workflow. Is basically a very tedious process that takes up a lot of time if you go through manually. We want to make sure that this tedious process, this manual process that takes up a lot of time is cut down into 1/10 of the time, and it should get you the same insights as you do as in manually. So that's how we came with the initial MVP of Ragas, and we released an open source library like mid of 2023. And since then, we have been continuously iterating, and we have been getting organic growth and usage from there. And that's what we are trying to do.
Yeah, that's awesome. I noticed that you very specifically refer to the evaluation of LLM applications, not necessarily the evaluation of LLMs. Could you explain like what might be the difference between those mindsets for people that are maybe getting into this? Maybe they have looked at benchmarks, let's say, for or like a leaderboard for LLMs, right? And there's a certain level of, evaluation or benchmarking there. But then you're talking about the evaluation of LLM applications. So could you help us understand kind of some of the differences there, some of what needs to be thought of at the application level versus at the model level?
This goes to the ideology of AI as a consumer product as of now, because pre LLMs, everyone, most of the enterprises or most of the startups who are building AI powered applications used to have their own models, and they will obviously also have a team of data scientists who is building and managing these models. So in that spectrum, the building of the LLM itself, or the model itself, and also the evaluation of the model itself was the responsibility of the researcher, the slash engineer slash data scientist who were working on it. But now it's not that people who are building LLM applications or AI applications is not really building their own models. They are consuming models from an external endpoint or even open source models that are being released, and building applications on top of it. Now this actually forms a wide spectrum, where at the left end of the spectrum there are people building the LLMs itself. They have a separate list of targets, loss functions, metrics, and benchmarks to evaluate on. And towards the right end of the spectrum, there are people who doesn't really care about how the LLM is built itself. They only care about, can this thing which I'm consuming using an API do what I'm trying to do here using this AI as a technology. Now, when a researcher or an organization like who builds LLM evaluates LLM, they don't really know what is the exact use case for which this AI or LLM is going to be used against, or the type of data this will be used against. No, when the evaluation is done at the researcher or an LLM builder part of the spectrum, they are limited to the evaluation or testing of these LLM's capabilities on a general purpose basis. They are not really tailoring this evaluation or testing to your application, because they don't really have a control over what you are trying to build with it. They can only say that, okay, this is a general capability of the model, and we know that even the general capabilities of the models and benchmarks are highly leaked into the training data, and even that is questionable, but that's a different question. This is what a researcher or LLM builder does at his end. But when it comes to LLM application builder, he can't really, if someone builds a RAG or a tooling agent on top of an LLM, he can't really say that, okay, the LLM builder has said X and X accuracy, so I should get X and X. That would be a wild assumption to make. So what we are trying to do here is giving that user, a application builder who is at the right end of the spectrum, the power, the required tools to evaluate his application without knowing so much about ML or getting into so much jargon or anything. We want to make it as easy as possible, so that and as intuitive as possible, because most of the people who are building AI applications are not from an ML background. They are from a software engineer background or application background, where their specialty is building and scaling these applications, not building and scaling the models. So we are trying to be intuitive as possible. We also want to make sure that we do not take a lot of their time while doing the evaluation itself. We want to make sure that their time is valuable, and we want to make sure that we do the heavy lifting of these evaluations for them.
Yeah, that makes a lot of sense. And also I'm realizing there's this kind of spectrum that I was thinking about while you were talking. On the one side, you have kind of data scientists or researchers who are building out benchmarks or metrics for models. On the other end of the spectrum, you have maybe software engineers who are used to writing unit tests or integration tests for their software. And then, like, what we're really talking about is integration of LLMs into software applications or into certain workflows. You talked a lot about kind of this distinction between LLM benchmarks and evaluating LLM applications. Could you talk a little bit about the differences? Maybe there's software engineers in the audience that maybe they're used to writing unit tests and integration tests for their software. Now, as a consumer, like you said, they're integrating some LLM functionality or maybe a reasoning, chain of reasoning with LLMs into their software. From a practical standpoint, what are the new types of things that they might need to consider that are different maybe from the way that they've unit tested in the past or written tests in the past now that they're working with these LLM workflows?
Sure, that's a very interesting question. So when it comes to the application builder slash software engineer who's building with AI, as you said, most of them are already familiar with unit tests and integration tests that they regularly write for their softwares. Now, the major difference is that I also have observed many of the software engineers who are relating to evaluation using this analogy. Okay, this is testing. I am I will learn or understand evaluation using the my understanding of the testing. So the thing is that this is a fundamental thing about analogy itself. So now you are using analogy to understand one thing, but it could be that these two things can have different physical and chemical different properties here. For example, now for when it comes to evaluation and versus traditional software testing, traditional software testing is mostly a discrete space where you have an input, you have an expected output, and if you give this input, you are supposed to get this expected output from the software. There is no variation in that satisfies the test. Now, if the logic is basically to add 1 + 1, you should get if the whole logic is basically addition. If you give input as 1 + 1, the output should be 2. There is no other possibility that exists that would satisfy that test case is correct. But when it comes to natural language, there is more of a continuous space. Like if you have an LLM that does the same thing, let's say 1 + 1, or addition, LLM could even say 2 in natural language or 2 in the decimal point numbers, right? So both are actually correct. So here there are like a continuous space where the output cannot be exactly matched against or asserted against, but you should have an understanding. But there is in this continuous space of outputs that are possible, there's obviously a subset that is actually can be regarded as correct. Obviously, if the LLM gives an answer as 3 in natural language or something, that means wrong. That is out of the way, right? So out of ballpark answer. So what software engineers should really understand is that when you deal with ML, when you integrate AI into your application, you should try to think about it as in a continuous space rather than a very discrete space of or in a black and white manner. It's yes or no. It could be that it is like in the middle of it. There are like a lot of space in the gray area here, right? So that is what a software engineer should understand. And then there is also a non-deterministic part of the whole a thing. Basically, if you have a system which is part of core and part of AI, the system is going to be somewhat non-deterministic. Whatever you do. So this is also something that traditional software is not like that. Traditional software is very deterministic. So you have an input, you will have an output, given that the intermediate states remains the same. So here again, you have this non-deterministic thing to take up call for. So that's also one thing. These are the two major differences that exist between software testing, traditional software testing, and this AI application or compound AI application testing that makes it different from each other.
Yeah, super interesting. And I know in the software world, there's all of these sort of frameworks for development around, test-driven development or data-driven development or these different things. I notice in Ragas, in your core concepts in your documentation, you talk about metrics-driven development for these LLM applications. So for those that are maybe developing LLM applications out there, could you describe a little bit the mindset of metrics driven development, what you mean by that, and then maybe we can get into a few more of the details of Ragas itself and how you enable that framework.
Yeah, metrics-driven development is a highly, is a concept that we took from the test-driven development itself. So the idea we want to educate developers, like software developers who are not familiar with metrics, but they are familiar with testing to, what we are trying to do here. So as I said, metrics versus test is like metrics is like something that delivers a value or, that helps you understand the performance of some application in a scale of let's say 0 to 1 or something. Now whenever you have an application, if you want to iterate or change, let's say you are building a whole LLM application that consists of different agentic workflows plus a rack workflow, etc. And now let's say you want to change one single prompt or one single function call or something, or even the retriever. How would you understand the effect of this change in your pipeline? Is a question that metrics-driven development tries to answer. So if you have a metric, if you have a way to objectively quantify or understand the performance of your system before and after this change, you can also understand and analyze the system's responses or the behavior of the system using these numbers. For example, if you are switching out the retriever and let's say you had a set of matrices that effectively quantifies the performance of your system, you could actually switch out the retriever or switch out any function calls or something, and then run the entire pipeline once again for the given test set and understand the change in the matrices in particular dimensions. And okay, let's say once you observe this change, you could again easily dig down. Okay, you could easily fetch these samples for which the change is reflected the maximum, and then you could easily analyze and understand them manually. That actually helps a lot, helps and reduces a lot of time when it comes to debugging and testing these applications. So that's the idea of metrics-driven development.
What's up, friends? I'm here with a new friend of ours over at Assembly AI. Founder and CEO Dylan Fox. Assembly AI is where you can turn voice data into insights, chapters, transcripts, summaries, and so much more with their leading speech AI models. So Dylan, give me a glimpse into what you're doing with speech AI models at Assembly AI.
So at Assembly, we're building industry-leading speech AI models for various tasks like speech to text, streaming speech to text, speech understanding, to help developers easily convert voice data, whether it's live or pre-recorded, into super accurate text, and then to help developers extract a ton of information and metadata around voice data or even around the text that they just were able to convert from that audio data. So these are things like picking out entities or PII that was spoken in voice files, or summarizing voice and audio data down into custom summaries. It's things like being able to detect how many speakers spoke and who said what and what the names of different speakers were. So we bundle all those things into a super simple API with really great docs that developers can just sign up to for free to start, use the API, build into their apps, and then build these really cool AI apps and products and workflows and automations on top of voice data with.
I dig it. Okay. Can you take me a little deeper into the opportunity for developers? Because it seems like there's a lot of voice data out there and there's a lot of trapped value in that voice data.
There's so much voice data being created on the internet now. Podcasts, videos, phone calls, voice messages, audiobooks, virtual meetings. It's crazy. And you can now transform and understand all of this voice and audio data in ways that were not even possible a year, 18 months ago. So what we're seeing with the help of these new AI models that we're creating at Assembly, developers and organizations are just racing to build all these new applications, workflows, automations that leverage the voice data they have either within their organization or within their product to build really cool new products and services and workflows that are just like taking off in the market. So at Assembly, we're building the industry-leading models for all those different apps and workflows, whether it's speech to text or speaker diarization or speech understanding capabilities to summarize voice data or extract entities from voice data or mask PII from phone calls for various types of automations that might be built. And we're exposing that through a super simple, super scalable API that's just constantly being updated and constantly getting better. And so we're seeing a crazy amount of developers and companies just build really cool apps and services on top of our API every day. It's really only just getting started, especially with the model updates that we have planned over the second half of the year that are coming out. They're really excited to launch to the developers on our API.
Okay, constantly updated speech AI models at your fingertips, well, at your API fingertips, that is. A good next step is to go to their playground. You can test out their models for free right there in the browser, or you can get started with a $50 credit at assemblyai.com/practicalai. Again, that's assemblyai.com/practicalai.
There's a lot that you've already integrated into Ragas, which are really interesting and maybe some people have heard of or some people haven't, like faithfulness and context recall, noise sensitivity, aspect critique, summarization score, and more that I'm not listing. I'm wondering if you could maybe just share a couple of those that you think are maybe most utilized or maybe interesting from your standpoint, just to give a sense of people, like what types of metrics are we talking about here?
I think it would be beneficial to answer that in an abstract level. For example, if I say metrics, the whole concept of we devising or giving the developers these metrics is that it's not extremely hard to come up with these metrics, but it is when a software developer or an AI application developer thinks about evaluation, because he's not really familiar with these concepts of putting up metrics, designing the right flows and everything. It could take him like 2 to 3 days to figure out the right metrics. So what Ragas does is, if you are an application developer, okay, you are developing this particular type of application, you can come to Ragas and you can go to Ragas metrics, and there you will find enough workflows, enough parts in the documentation that can help you navigate according to use cases, according to requirements, that can land you up in the right metrics that you should use. And the documentation will also provide an intuitive understanding of how this metrics is calculated underneath. So these are the two value props that we provide there. It's not that a developer can easily, a developer or a data scientist could easily make up these metrics as their own. But sure, if it is mostly, if you are a software developer or application engineer, it could be very hard for you to figure out, have to think around all these stuff. So we are effectively taking that load of you and providing you the ways to easily navigate and understand the right metrics to evaluate your application, tailor to your application. Now we are also expanding. We are also expanding the list of metrics to two use case and agentic workflows, and we are also going to reformulate the whole docs around that particular, so that people can easily find the metrics. For example, metrics can be LLM based or non-LLM based. So these are all, whenever a developer comes to Ragas, he obviously asks a lot of questions, or even think about metrics. He will ask a lot of questions like, for example, okay, what is my use case? What are the parts in my application that I want to evaluate? And then what should I go for? LLM based metrics, which has high correlation with human judgment, but also has its own lack of its own issues, like non-determinism and everything, or non-LLM based metrics, which are traditional. It has less correlation with human agreement or human judgment, but it is more reproducible. So all these questions, all these doubts pop up in mind when a developer think about metrics. We are trying to abstract away all that into Ragas metrics and provide the developer a way to think about metrics. And with metrics, they're also, when they adopt a metric from Ragas, they will also have a related list of items or features that they can use because they adopted the metrics from Ragas. For example, let's say you designed a metrics for language English. Now, let's say you are evaluating for Portuguese or Spanish. You'll have to convert it to the other language or whatever. Whenever you're evaluating different language, you'll have to do that. Now, Ragas could, if you're using a metric from Ragas could take care of that. Then there are also issues like if you are building an LLM based metrics, which is the trend here, and most of the Ragas metrics are LLM based metrics. because that has high correlation with human judgment. Then, okay, let's say the LLM, you are evaluating with LLM based metrics, and you are finding that the LLM based metrics is actually it's actually not performing well enough in your use case. You should have a way to align these LLM. The people will have different expectations for different metrics. For example, let's say you are trying to do something like faithfulness, and faithfulness is basically the amount of hallucination or that is happening in the generated answer given a context. And if you look at it, different developers from different domain has different strictness towards hallucination. I could have a statement like, I have a blue car and versus I have a car. And I could, for me, maybe in my domain, I could say that these are two equal statements. But for someone who is working in fintech or something, it might not be equal statements. So there is also a domain kind of bias when it comes to matrices or in judgments, because developers from the different domain expects different level of strictness and everything. So bringing out this alignment with these matrices depending upon your domain is also one extra thing that we are trying to tackle here, which is called, basically we call it as a metric alignment, that is trying to align large language model judges to your specific judgments using the feedbacks that you can give to LLMs. It is also an upcoming feature in Ragas.
I want to just dig into a couple of those things. So one is like you talk about alignment, but also there's like the idea of, it's very important in this case for me to be thinking about data and examples from my domain in terms of how I'm evaluating these. So I'm just looking through, just to make things for concrete for people, looking at your example around answer relevance. And there's data samples in there that have a question, an answer, and then a set of context. And then you can evaluate with Ragas using the metric answer relevancy. So obviously there's a data component there. And in that component, there's, answers that are there and contexts that are there. So one question would be like, how much and what type of data will people need to configure such that they can appropriately evaluate their LLM applications? And are there metrics that require sort of data upfront, or metrics that maybe are reference free that wouldn't require data upfront? What's the perspective there in terms of kind of, I guess, the cold start? Like if people are starting an LLM application from scratch, they haven't run it in production, what's the data burden and the path towards both getting this data in place and getting the alignment in place?
So regarding the data itself, the number of samples people generally use to evaluate is around 100 to 500 when it comes to offline evaluation. So it really depends on how you formulated your test data itself. So for example, you could have the same results or same kind of ranking when you have 100 samples data point, or in many use cases, even 100 may not be enough to include all the kind of use cases or all the kind of distributions that you see in production. So it really depends on the variety of items that you see in production, that you expect in production. Then let's say you have a very niche, use case, and the variety is very, very skewed. Your test data can be very small, yet still serve the purpose. But if your use case is very broad and you see a wide variety of users coming into your application or a wide variety of requests, your test data has to be broad enough to include all these different distributions in the data set itself. So that's about the number. And ideally, it's not really about the concrete number, but again, basically making sure that you understand what are the different distributions of queries coming into your system, and also making sure these distribution of queries are also represented in the test data set, so that when you change a probe or when you change a prompt, which type of queries are being affected. It could be that when you change a particular retriever or particular tool or something, when you swap out a particular tool or something, it could be that a specific set of queries are being affected. The overall pipeline almost never gets affected if you don't do a huge change. Where for the small changes, it's mostly a subset of queries, a subset of distribution that gets affected. And it is very important that you identify these items. So that's about the how to formulate a test data set itself for evaluating AI applications. And regarding the second question of metrics and reference free and the with reference metrics. We usually provide both reference free and reference with reference metrics, but there is a big shortcoming to reference free metrics itself, because reference free metrics are basically, we could estimate things there, but there is an error to estimation with reference free matrices. For example, answer relevancy, or you could estimate with some way that if the given answer was correct or something, but if you don't really have the exact thing somewhere noted down, it's really impossible to say that okay, the LLM application arrived at the right thing at the end of the day. So there, what we provide, even with production data, it's very hard to acquire a test data set, because again, with production data is very, very messy. It's a common thing that people if you ask any researcher or an ML guy who has put MLs into production, models into production, and the method of acquiring test data set, obviously they are going to look at production data, but the way in which test data set are being acquired is, there is a long way to go from production data to formulating test data, because production data is incredibly messy, because it's an uncontrolled environment. It's not an human annotated controlled environment. People can come and say anything there, and they have like zero consequences, like, right? So the thing is that production data becomes incredibly messy depending upon the application. If you have, let's say, if your application is serving an internal set of users, like an internal company employees or something, still you have an amount of control there. But if your application is strictly B2C, and you are opening up the whole application to anyone using your application, there can be users who are basically trolls who just like to use your system and leave out false feedback and stuff. So production data being incredibly messy, there is a long way from going from production data to to a good test data set. So there again, what we are trying to do is providing a way to synthetically create these test data sets. Now, these synthetic creation of test data sets will be grounded on things like from production data. Then there are your internal documents that should be taken into account when creating a synthetic test data set. Because again, you are trying to create a test data set that's very tailored to your use case and not a generic one. So there are 2 points where we ground it, basically the set of internal documents or whatever you have that you ground your application, and also the production data where the user engages with your application. And when this is again one of the upcoming features, the test data set generation is already there, but we are also trying to extend it to a way that we could ground these into the from production data. Basically, we call it seeding from production data. Basically, if a user has been already using Ragas test generation, but he wants to take motivations from production to imitate more behavior in the test data set that is also happening in production. Now, there is like a long tail of things that has to be done to make sure that to first understand what is happening in production. There can be different distributions, again, as I said, different set of users. We have to understand different set of queries that's coming in, different set of interactions that's happening, and everything. And once then we understand that, we could also have a way to synthesize these type of data points using LLM itself. Now, the developer's job will not be to annotate these data points, but to verify these data points. Once this data or test data is synthesized by Ragas, you could export it to a simple, UI UI tool, and then you could simply, or even Excel sheet tool. Most of the users could export this data to an Excel sheet, and basically they go through it. And then once they go through it, they can easily, cut out the bad data points that they think is LLM messed up or something. Because again, we can't really guarantee 100% efficiency while synthesizing these data points. So what we are trying to do is improve the efficiency. Let's say if you generate 100 data points, our goal is to make sure that all the 100 data points are equally valid and good. But it might not happen like that in every use case. So developer can take 10 minutes of his or her time and go through this data set manually. It is a fairly quicker process than annotating or creating these data sets, because creating these data sets would easily take a day or two, or even a lot of money when you give it to other human annotators. So developer basically can go through this data points that's been synthesized and then cut out the points that he thinks that is not valuable. So again, that is again one. These are actually the real ways in which we save a lot of developer time in evaluation. Because again, formulating test data set is it's a very cucumber stone. It's a very time consuming, boring process that nobody wants to. and it mostly falls upon one developer and the team to do it, and it's a messy process. So these are the type of innovations what we are trying to bring in the evaluation space itself to save a lot of time of the developer. And this ideology or this philosophy is why we have been getting this organic growth, because it is very kind of hard to come up with these kind of solutions. But when we come up with these the kind of solutions, there are a lot of developers who are who badly wants this, and they are the people who motivate us to continually bring these kind of innovations to the evaluation space.
Yeah, that's great. I love the innovations around synthetic data use in evaluation and utilizing kind of the LLMs and these models to help in the evaluation process, but in a way that's validated and still fitting with improvement over time. So yeah, as we kind of close out here, this has been a fascinating discussion. But maybe just to close out here, what are some of the things that you're excited about moving into the next 6 months or so to either explore, or maybe it's things that you see happening in the AI ecosystem more broadly? What really excites you about the direction that people are going with their LLM applications?
So with LLM applications, with early 2023 or mid 2023, RAG was a big thing. And if you remember the time when RAG became popular, there was again a lot of limitations. Like there were only 4K contexts, or LLM was hallucinating and everything. I think with agentic or tool use cases, we are at the same level as of now. We have been trying to bring more and more tool use cases. Tool use cases are actually incredibly useful when it comes to building a whole LLM application experience, because combined with internal knowledge is what you can infuse with RAG, and then taking actions is something that infuse with tool use cases, tool bindings. So if in a tool binding, I'm very excited to see the next class of models performing better on tool use cases. Again, now even these recent models have been bringing abstractions, or being using tool binding to facilitate this, but still it's a little bit shaky as of now. But the next class of models, I really expect it to be better, and then the whole thing with RAG plus tool use case, we will see a lot more enterprises adopting and using LLM applications at different capacities, and it saving a lot of time and resources for both people who are at the back of these applications, and also people who are interacting with these applications. So that's something I'm really excited when it comes to the very next 6 months of LLM applications itself. And also, I think when it comes to the frameworks or libraries that are being built around applications, I'm seeing more and more better abstractions these days when it comes to these frameworks and libraries, because people now has almost 1.5 year of building with LLM application experience. Now that experience is yielding more and more understanding of what is the best abstraction to be used to build these applications and everything. And then there is an overall agreement that is coming up with what is the, how to format outputs, how to build these compound systems itself. Because earlier, the first early 2023 and everything, people were really confused on how to build these applications, how to use AI and everything. Now that clarity, I can see that more clarity is happening at that end too. So at the model building stage, again, the model building spectrum, we are again having more clarity on things like the behavior of the models, the type of data needed, more and more papers and more and more research happening at the data processing and pre-processing stage. What is the type of data needed to train the higher quality and best quality LLMs itself? Because we think that we have mostly settled on the architecture itself from that point of LLM builder point of view. Now the main thing people are working on this data. Again, when it comes to data, people are again now mostly we will finish up the free data that's available on the internet very quickly, and now it's again synthetic data that has a really good chance of improving these models itself. So the idea of models output being used to feed models and improving the models itself for different use cases is itself a fascinating thing regarding the model building stage. When it comes to evaluation, there needs to be more and more innovations. happening in the evaluation space itself, whether as an open research or as an open approach to bringing down the time involved in testing and assessing these applications itself, because that's one big pain point on why the enterprises or big companies could a big barrier for these big companies to adopt LLMs or AAs in their system, because these people, they have high responsibility. So when with high responsibility, you will have to do these testing and evaluations, and there is no very good way of doing it and agreed upon way of doing it. It becomes a pain point, and that's something we are also trying to bring in. We are trying to formulate all the research, all the innovations that are happening in the evaluation space to come together and build an open source standard for evaluating LLM applications itself, so that there is an agreement between everyone on how to evaluate LLM applications. And that's the long-term vision of the company itself.
Awesome. Yeah. Well, thank you, Shahul, for taking time to join, and again, joining at a late hour where you're at. I'm really excited about what you're doing with Ragas, and this is a really interesting space that we'll be interested to follow. So thanks for taking time, and hope you can have a good rest of your week.
Sure. Thanks, Daniel. This was fun chatting with you, and I hope your users learned something from this conversation.
Yeah. Thanks. Bye-bye.
All right, that is Practical AI for this week. Subscribe now. If you haven't already, head to practicalai.fm for all the ways. And join our free Slack team, where you can hang out with Daniel, Chris, and the entire changelog community. Sign up today at practicalai.fm/community. Thanks again to our partners at Fly.io, to our Beat Freakin' residents, Breakmaster Cylinder, and to you for listening. We appreciate you spending time with us. That's all for now. We'll talk to you again next time.